All right, this is lesson 9.1 on simple probability. Today our learning intention is that we are learning to determine simple probabilities and use them to predict future outcomes. Will you know when you're successful? You should be able to determine the sample space, which we'll talk about sample space being all the possible outcomes. You can write probabilities in fraction form, decimal form, and in percent form. That goes back to when we just did fraction, decimal, percent. So generally you're going to start with the fraction, write the probability as a fraction. You'll be able to convert that to a decimal and a percent. All right, find the probability of complementary events. We use the word complementary in geometry to talk about angles that add up to 90 degrees, but this is different. Complementary events add up to 100% or add up to one whole. Okay, and then classify all probabilities. We're going to classify them as impossible, unlikely, equally likely, or just as likely, if you talk about it that way, likely, or guaranteed certain, and use proportional reasoning to predict future outcomes. Those are we'll know we're successful when we can do those things. All right, so just to understand what probability is putting it on this continuum between down here at 0 or 0% and 1 or 100%. That means probability has to be between 0 and 1 or between 0 and 100%. Okay, you can't have 200% chance or 150% chance, right? Has to be somewhere in that range. If it's a 0% chance, it is classified as impossible, right? Can't do it. Okay, so we'll talk about a couple of those things that are impossible. If you have a 50-50 chance, you've heard of a 50-50 chance, it's like a coin flip, right? It's either heads or tails, right? That means there's a 1 chance out of 2 that it's a heads. So there's a 1 chance out of 2 that it's a tails, right? That's a 50-50 chance on each one of those. If you change that to a decimal, it'd be 0.5, 50%. Okay, that means it's equally likely. That's why they call that a coin flip. That's why they start football games with a coin flip. It's because it's equally likely that either team will get the ball first or whatever. So, and then if it's more than 50%, like 62%, 51%, 62% would be up here, 75%, 94%, any of that would then be considered likely. It's going to happen more often than not, right? And then finally, if you get to 100%, we call that certain. It's going to happen. Okay, that's if you have a 100% chance. All right, so probability is the chance or likelihood of an event occurring. How likely it is to occur, what the chances are of it occurring. So we're going to look at a couple of those. These are called simple events. So for example, I have a spinner up here, and I want to know the probability, and the way they might put that is they'll put a P and then a parenthesis, and they'll put what they want with probability in there. So what's the probability I get candy? Okay, well, I count up the sample space. The sample space is the collection of all the things that could possibly happen. So I could get fish, I could get pickle, I could get car, I could get candy, I could get cat. Okay, those are all equally likely because the sections are all the same size. I'm equally likely to get each one of those, which means it's a random spin. Okay, and now all I have to do to figure out the probability is take the number that are in the sample space. I have 5 possible outcomes. And then how many of them are candy? 1 way. The formula for this is basically the number of ways that it can happen to the total number of outcomes or ways. Okay? So the probability of candy is 1/5. If I said, what's the probability that the category I get starts with a C? Now, there's still 5 things that could happen. That's still my total sample space down there at the bottom. How many of them start with a C? Cat, candy, car. I have 3 ways to win that. So again, there's 3 of my cans out of the 5 total things that could happen. Now if I go back to this, pull 1/5, of course, we know how to change that to a decimal. We could take the top number, divided by the bottom number, put out some zeros and start dividing. It becomes 0.2. We could bounce the decimal 2 times and it would be 20%. So now we have 0.2, 20%, 1/5. Those are all ways of writing it. That's the probability. Now if I were to classify that, if I go back 1 to this section, where would 0.2 or 20% be? It'd be right down in here, right? So that I would consider that unlikely. It's unlikely that that happens. All right? Oops, wrong way. If I do that with the 3/5, I could do that again. 3 divided by 5, put out zeros, start dividing, it becomes 0.6, it's 60%. Now where would I place that? 60% would be up in here somewhere, right? And now I would consider that likely. All right, keep going back that way. So I have now those two. We could also talk about the complementary event. Remember what I said? Complementary events add up to 100%, right? So the complement would be, what if I said, instead of starts with C, I would just put the word doesn't. If it doesn't start with a C, right? If there's 3/5 way it will start with a C, then I could just say, well, there's then 2/5 that it will not start with a C. So what's the probability I don't get candy? Okay, probably I don't get candy. Well, if there's one way I can get candy, that means there's 4 ways I can't get candy. So we can be getting what are called the complementary probabilities. All right, let's try with another one. Let's go with the quarter. What's the probability you get heads? Well, how many are in the sample space? You could either get heads or tails. There's 2 in the sample space. They're equally likely, right? There's one way to get a head, so my probability is 1/2. I could divide that. It, of course, becomes 0.5, which is 50%. If I wanted its complement, what's the probability that by the way, this is what I did, probability heads, right? If I want to change it to its complement, I would just say probability not heads. Well, probability not heads is going to be all the other options. So that means the 1/2 plus the complement have to equal 1, right? So the complement's going to be 1/2. Again, 50% chance. We would consider these what? Equally likely or just as likely to get a heads as a tails. That's why we call it a coin flip. All right, let's try another one. The die. What if I said, what's the probability that I spin a 5? Well, a lot of people just put a 5 on top. No, there aren't 5 ways to get a 5. How many 5s are there? There's 1 5. Out of how many possible outcomes? Well, you could get a 1, 2, 3, 4, 5, or 6. Those are your sample space. There are 6 in the sample space, so that I have a 1/6 chance of rolling a 5. Okay? What if I said probability, and here's the first extra word that I want to do, is that you get either a 2 or a 3. Now what we do, either or, okay, is going to denote that we're going to add the probabilities together. So the probability of getting a 2, don't I have 1 way out of 6? And probability of getting a 3, don't I have 1 way out of 6? And so now if I add those together, I have 2 ways out of 6, which I would then simplify to 1/3. I have a 1/3 chance of getting that done. And of course, we could change these to decimals. We could change them to percents. I'm not going to teach a lot of that. We've done that a number of times. We can start with the fraction. You can always just divide, make it a decimal, bounce the decimal twice, make it a percent. So I would consider this one unlikely up here. And this one is unlikely up here. Now if I said what's the probability it's not a 2 or a 3? Well, if there's a 1 out of 3 chance it is, then isn't there a 2 out of 3 chance that it's not? Because again, 1/3 plus 2/3 needs to equal 1. This one, it's likely that I don't get, right, a 2 or a 3. All right, let's go to the box down here. We're drawing one of these little rectangles out of the box. What's the probability I get red? Give you a second to think about it. Hopefully you're answering. And you got 3 out of 7. Of course, I'm counting them. 1, 2, 3, 4, 5, 6, 7 possible outcomes. Now you might say, well, there's really only 4 colors: green, red, purple, or black. But I want to make sure they're equally likely. You're not equally likely to get black or red because there's 3 times as many reds as there are black, right? So I need to count them individually and say, well, I have 7 possible things. That's my total in my sample space. And 3 of them are red. So I have a 3 out of 7 chance of getting a red. Okay? And you can think about that. You could divide it if you wanted to. You can get a really ugly decimal that's around 0.429. And then you could bounce that decimal twice. You'd be at 42.9%. We would consider that unlikely. Unlikely. Okay? You ready? Let's try another one. What if I said, what's the probability I get either purple or black. Probability either purple or black. Remember what either or means? You're going to add the probabilities together. So the probability of getting purple, 1 out of 6. Probability of black, 1 out of 6. Add them together, you're going to get 2 out of 6, which simplifies to 1/3. Still unlikely. What if I said the probability red or green? No, let me do probability red or purple, sorry. All right. What's the probability to get red? Well, 3 out of 6. What's the probability to get purple? 1 out of 6. Add them together because it's either or, and you get 4 out of 6. Simplify that to 2 out of 3. If you divided that, you'd get 0.6 repeating, or 66.6 repeating %, and now we're actually in the likely category. So to review what we've talked about so far. Okay, we've talked about what sample space is. What would the sample space be for the dice? Well, you get a 1, a 2, a 3, a 4, a 5, or a 6. So you can list those. The sample space is actually this. Now, for probability, what we need to know is how many are there in there. There are 6. And so if I start asking about probabilities with that dice, you're going to start with 6 on the bottom because that's the total number of outcomes. So, real quickly, what's the probability to get an even number? Well, 2, 4, and 6. I have 3 ways to get that done. I'm at 1/2. We would consider that just as likely or equally likely. Okay, what's the sample space for the quarter? Sample space is heads or tails. That means the probabilities are going to start with 2 on the bottom. Okay? What's the sample space for the spinner? Well, I'm either going to get candy, cat, fish, pickle, or car. How many are there in there? There's 5. So my probability is going to start with 5. If I'm doing it with the probability of the box, I can either get black, purple, red, 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 green, or green. So I count those up. My probability is going to start over 7. And that's how we consider that sample space goes into the bottom number in the total number of possible outcomes. And we're talking about how many ways we can get them done. Now, the last step is to think about it proportionally and start thinking about, if I want to say, okay, what if I drew out of this box 80 times? How many reds would I expect to get? Well, I would start with the probability of getting a red. Probability of getting a red is 3 ways to get it out of 7, and then I would just set up a proportion. If I'm getting a red 3 out of every 7 times, and you know me, I'm going to use my labels, that's 3 reds out of this many total draws. Okay, by the way, you'd have to be putting them back in. You'd have to be drawing it out, looking at it, and putting it back in. We'll talk about that in another lesson. It's called with replacement or without replacement. We're going to draw, look at it, record it, and put it back in. Because obviously you couldn't draw 80 times out of that box if you weren't putting them back in. Now, we're going to draw 80 times. So all I got to do is, of course, solve my proportion. 3 times 80 divided by 7, right? And you could just do 3/7 of 80. That would be another way of doing it. But we're going to say 34.3, so we're going to expect to do it about 34 times. Now, one thing we want to talk about probability. That doesn't mean you're guaranteed to do it 34 times. Is it possible that you drew 80 times and never got a red? Yeah, it's possible, but it's not very likely, right? Is it possible that you drew 80 times and got all reds? Yeah, it's possible, but it's not likely. It could happen, but it's probably not going to happen. What we're expecting is to get about 34 reds. Would I be surprised if it was 32? No. Would I be surprised if it was 37? No. Okay? The more times I do it, though, the more likely I'm going to be to pretty close to that number. So if I drew 800 times, I wouldn't be a long ways off from 340. Okay? So let's try that again. This time, how many times would you expect to have to spin the die to get 35 threes? How many times would you have to expect to roll that die to get 35 threes? Well, probability of getting a 3 is 1 out of 6. That's 1 3 out of 6 total spins. And I want to get the 3 35 times. I'm ready to multiply and divide, right? That's how we solve that. Okay? Or you can just undo it like a fraction, and you're just going to multiply that and divide, and you're going to get 210. I'd expect to have to do that about 210 times to get 35 threes. All right, let's try it again. On this spinner over here, out of 72 times spinning it, how many times will I not get fish? So I'm looking for the probability of not fish. Now I can't remember what number I said. What did I say? 70 times? I don't know. 70 times. We'll say 70 times. 70 spins. All right. Well, what is the probability you don't get fish? Well, the probability you do get fish is 1 out of 5. So the probability you don't get fish is its complement, 4 out of 5. So there are 4 not fishes out of 5 total spins. And now we want to spin it 70 times. You're ready to multiply and divide. I'm predicting, once again, predicting the future. If I did this 70 times, I'd predict to not get fish about 56 times. Again, not a guarantee, right? But now we should understand simple probability, setting it up as the number of ways something can happen over the total number of outcomes. If you listed all the total outcomes, that's called your sample space, right? Okay, and now we talk about the complement. The complement is if you put the word not in it or doesn't, or, right? What's the probability you don't get a 5? Well, there's 1 out of 6 that you do get a 5. There's 5 out of 6 you don't get a 5. Those added together will always equal 1, the complementary events. All right.